Welcome back to QHSE Talks. Back in 1974, there was this chemical plant in England, and they needed a really quick temporary fix for a leaking reactor.
Right, the Flicksboro disaster, a classic tragic example.
Exactly. They installed this temporary bypass pipe, and it was just supposed to be a minor change, right? Like a weekend fix just to keep production moving and hit their quotas.
Just a Band-Aid to keep the money flowing.
Yeah, but 2 months later, that temporary pipe completely ruptured. It caused a massive vapor cloud explosion that literally leveled the entire facility.
It's just devastating. It tragically took 28 lives.
28 lives.
Yeah.
And it permanently altered industrial safety laws all around the globe. And, that is the ultimate cost of unmanaged change.
It really is the ultimate cost.
So it is fantastic to have you back here in this space. This is where we take, a mountain of sources and research and guidelines, and we synthesize them into clear, actionable knowledge for you.
And today we have a very specific, very critical mission for this QHSE Talks.
We really do. We are taking a master class in ASP Domain 2, Topic 10.
Which is huge.
Oh, it's massive. For those of you tracking with the Associate Safety Professional certification, you know exactly what that means. We are mastering the management of change, or MOMU.
And looking at the stack of sources we have for you today, it's quite the comprehensive collection.
It's a heavy stack, for sure.
Definitely. We are pulling from the ISO 4501 implementation guides, the Center for Chemical Process Safety, or CCPS risk-based process safety guidelines, the Safety Professionals Reference and Study Guide, and also actual concepts derived from CSP exam practice materials.
It is a dense stack, like you said.
Yeah.
But it's incredibly valuable for understanding the actual mechanics of how disasters happen.
Right, because disasters don't just happen out of nowhere.
Exactly.
Yeah.
I want to frame this for you right out of the gate. This QHSE Talks is not just some audio flashcard session.
No, definitely not.
I mean, yes, mastering this material to pass the ASP or the CSP exam is the immediate goal for many of you listening. But the ultimate value of what we are discussing today is learning how to stop those catastrophic plant leveling incidents before they ever happen.
It's about learning how to manage the inherent chaos of change.
Yeah. Management of change isn't just paperwork, It is the very fabric of organizational safety.
That is the perfect way to look at it, because to truly grasp management of change, we have to establish a foundational reality about how businesses actually operate.
Right.
Organizations, from the boardroom all the way down, they often crave stability. Stability means predictable revenue, it means predictable output, and predictable safety metrics.
Everyone loves a predictable spreadsheet.
Exactly. But the reality on the ground is that operations are inherently dynamic. I mean, things break, personnel leave or retire, and they take decades of institutional knowledge right out the door with them.
Oh, that's such a huge risk factor.
It really is. And, new technologies emerge. Supply chains shift, which forces you to buy different raw materials.
Right. So management of change is the systematic, rigorous approach to managing all of those modifications in a company's processes, operations, or structure.
Its sole purpose is to ensure that absolutely no new hazards are introduced while the business adapts to survive.
Okay, let's unpack this, because why is change so inherently dangerous if it's left unmanaged?
Well, it's about the complexity.
Because, we change things in our daily lives all the time without catastrophic failure, right?
Yeah.
I buy a different brand of coffee, or I take a new route to work, and my life doesn't just explode.
Right.
So why is it such a massive red flag in an industrial or organizational setting?
It really comes down to complexity and interconnectedness. In your personal life, the systems are relatively simple and they're isolated.
That makes sense.
But an industrial environment is a highly complex, tightly coupled system. A change in one isolated area rarely stays isolated. It ripples out.
Like a domino effect.
Exactly. Think about a chemical pipeline. If a procurement manager decides to change a valve type because the new one is, say, 10% cheaper, that seems like a total win for the company.
A quick win on the balance sheet.
Right. But that new valve might have a slightly different pressure rating, or maybe it's made of an alloy that reacts just a little bit differently to temperature fluctuations.
Okay, I see where this is going.
Yeah, so that pressure difference might interact differently with a highly sensitive pump downstream. If the maintenance technicians operating that pump don't know about the new valve's specifications, their standard operating procedures are suddenly completely obsolete.
And they don't even realize it.
They have no idea. Unmanaged change is dangerous because it blindsides the system. It introduces these hidden variables that the existing safety controls, alarms, and procedures were simply never engineered to handle.
Yeah, That makes total sense when you explain the actual mechanism. It's kind of like updating the operating system on your phone, right?
Oh, that's a good analogy.
Like the new software inadvertently drains the battery twice as fast in the background. Suddenly, your phone dies in the middle of the night and your alarm doesn't go off for work.
Exactly. The software change solved one bug, but created a totally unforeseen secondary failure because the battery wasn't designed for that new load.
Right. Which brings us perfectly into the core philosophy of this whole topic.
Let's get into it.
Before we get into the technical steps, the forms, the flow charts, all the bureaucracy of MOC, we have to fundamentally shift our mindset.
A huge paradigm shift is required here.
The sources make a really compelling argument that for a safety professional, effective MOC requires moving away from asking, what are we doing, to asking, why is unsafe behavior happening?
Exactly. And to understand that why, we really have to look at the safety management errors theory that's presented in our sources.
This is such a vital concept for anyone evaluating organizational risk.
It really is. This theory dictates that incidents, accidents, and near misses are not just bad luck, and more importantly, they're rarely just the result of individual human error.
That goes against how a lot of people think about safety.
Oh, totally. Instead, they're the result of failures in the overarching safety management system. We are talking about systemic failures in risk assessment, hazard control, training, and yes, management of change.
There's a quote in the sources from Peterson, published back in 2003, that I think is just brilliant.
Oh, I love this quote.
It says, unsafe behavior is normal human behavior.
Let that sink in for a second.
Right. An unsafe act, an unforeseen condition, or an accident, those are just symptoms. They are the red flashing lights on the dashboard telling you that something is fundamentally wrong with the organization's engine.
It is a profound shift in perspective. Historically, safety was just about finding the worker who messed up and punishing them.
The blame game.
Exactly. But if management's job is to design and maintain the environment, then the safety professional's role is to facilitate the continuous improvement of that environment.
By identifying the root causes.
You got it. You do this by identifying the root causes of the hazards. You want solutions that actually change the organizational culture and the physical workspace, rather than just handing out a suspension to a worker who was, honestly, set up to fail.
And for an ASP or CSP candidate, understanding the mechanics of why this matters is just so crucial.
It's the foundation of the whole profession.
Right. But let me push back on this a little bit, because I know exactly what some managers would say to this.
I hear it all the time. Bring it on.
If I walk into a manufacturing facility and I see a worker blatantly bypassing a machine guard, my immediate instinctual reaction, and the reaction of most floor supervisors, is discipline the worker. They break the rule, so they face the consequences.
Sure, that's the natural reflex.
But when you look at how the certification boards evaluate this, they explicitly call out that disciplining personnel who violate the safety policy is the wrong approach to building a sustainable safety and health management program.
It's absolutely the wrong approach long term.
They say the correct approach relies heavily on employee involvement. But is that really practical? I mean, it sounds a little bit like we are letting people off the hook for dangerous behavior.
I totally understand that reaction, but you have to look at the causality. If you treat safety purely as an enforcement problem, you just become a police officer.
Right, a safety cop.
Exactly. You are just handing out speeding tickets on a dangerously designed road. Let's look at the mechanism behind that bypassed guard in your example. Why did the worker actually do it?
Well, they were probably trying to save time.
Right. If you investigate, you might find that the approved safety process takes 20 minutes, but management just increased the daily production quotas by 15%.
Ah, so there's a conflict there.
A massive conflict. The worker bypassed the guard because the environment, the intense pressure to meet those new quotas, incentivized the unsafe behavior.
So they're making a calculated risk.
The worker is making a rational, albeit very dangerous, trade-off to keep their job. If you just fire that worker, the next person you hire will face the exact same quota pressure and bypass the exact same guard.
Wow, yeah. You haven't fixed the hazard at all. You've just swapped out the victim.
Precisely. Safety management is fundamentally a motivational and environmental problem, not just an enforcement problem.
I see. Let me throw an analogy at you just to make sure I'm locking this in for everyone listening.
Go for it.
If I'm driving a car down the highway and the car violently swerves to the left every single time I hit the brakes, you don't blame me, the driver, for swerving.
Right, you're just trying to drive the car.
Exactly. You don't write me up for bad driving and tell me to try harder not to swerve. You look at the mechanical system of the car and say, hey, We need to fix the brake calipers.
That is a perfect analogy.
So in the context of organizational safety, if management of change is our mechanic in this scenario, how do we spot the broken brakes before the crash actually happens?
You spot the broken brakes by relentlessly monitoring the system for deviations and modifications. That is the essence of Mamato.
Relentless monitoring.
Yes. When you shift your mindset from cop handing out tickets to system architect, your day-to-day operations completely transform.
Because you're not just looking for rule breakers anymore.
Right. You are no longer just walking the production floor looking for someone forgetting their safety glasses. You are sitting in the early stage engineering meetings. Yeah. You are reviewing the procurement orders.
Looking at the decisions being made upstream.
Exactly. You are asking the fundamental questions like, why are we buying a highly flammable solvent this month instead of our usual water-based cleaner?
Right.
You are looking at the architecture of the work itself to ensure the environment inherently supports safe, efficient choices.
Okay, we've established that the system is responsible, and we know the system is constantly shifting.
Always shifting. Now we really need to define our terms here. We need to know what exactly constitutes a change that requires this massive management apparatus. Because obviously you can't manage what you don't formally identify.
Precisely. And this is where we turn to the framework provided by ISO 45001.
The gold standard.
The standard is incredibly clear and uncompromising on this. Organizations must establish processes for the implementation and control of both planned, temporary, and permanent changes that impact occupational health and safety performance.
So it's not just the big stuff.
No, it is not just about the permanent installation of a new multi-million-dollar robotic assembly line. It covers the minutia of daily operations.
Wait, let me stop you there. Because I was looking at the list of triggers in the ISO document, and it is just massive.
It covers a lot of ground.
Yes, it includes new products, new services, new processes, but it also includes changes to workplace locations and surroundings.
Yep.
Think about that just moving a workstation from a well-lit central area to a dimly lit corner of the warehouse is considered a change that requires management. It absolutely is.
Isn't that bureaucratic overkill? I mean, if I have to fill out a multi-page form and get a committee approval just to move a packing desk 10 feet to the left, production is going to grind to an absolute halt. How is that workable in the real world?
I hear that complaint constantly. It sounds like overkill until you trace the actual mechanism of failure. Let's take your exact example. Moving a packing desk to a dimly lit corner.
Okay, let's trace it.
Why does ISO care about that? Because lighting directly affects visual inspection.
Right.
If the packer is responsible for checking seals on a pharmaceutical bottle, the reduced lighting leads to eye strain and micro errors. They miss a compromised seal.
Oh, wow.
That bottle goes out, the medication degrades due to air exposure, a patient gets sick, and you have a multi-million-dollar recall and a massive liability on your hands.
All because you moved a desk 10 feet without assessing the impact on the process.
Exactly. MOC forces you to ask, if we move this desk, do we need to install supplementary drop lighting to maintain our quality and safety standards?
The bureaucracy isn't there to slow you down. It's there to force you to look around corners you didn't even know existed.
That is exactly it.
Wow. Okay, when you trace the causality like that, it makes perfect sense. A drop in lux levels equals a drop in quality control, which equals a catastrophic failure downstream.
It's all connected.
And the study guide material breaks these changes down even further into top-down changes versus unplanned changes, which I found totally fascinating.
It's a really useful distinction.
Top-down changes are initiated and directed by management, right?
Yeah.
They're usually strategic, comprehensive, and when executed well, they occur quickly with widespread impact. Think of a company-wide software rollout or a massive restructuring of the management hierarchy.
Yes, top-down changes are highly visible. But then you have the unplanned changes, which are often insidious.
They sneak up on you.
They really do. The text notes that these occur spontaneously or randomly, totally without a formal change agent's attention. They just bubble up from the realities of the floor. And they can go two ways.
Good or bad?
Right. They can be incredibly destructive, like a wildcat strike.
Let's define that really quickly for anyone listening. A wildcat strike is essentially an unapproved, spontaneous labor strike by unionized workers without the authorization of union leadership. It's sudden and it's chaotic.
Exactly. And from a safety perspective, a wildcat strike is a massive, unplanned change.
Because everything just stops.
Suddenly, operations halt, Management might try to keep the plant running using a skeleton crew of unqualified office staff, or they force the remaining non-striking workers into dangerously long, fatigue-inducing shifts.
So the risk profile of the facility skyrockets in a matter of hours.
Yes, entirely unmanaged, but unplanned changes can also be unexpectedly beneficial.
Oh, really? Like how?
The text gives a great example of an interpersonal conflict on the floor, say, two teams arguing over floor space.
Your normal workplace friction.
Right, but that friction actually forces the workers to develop a brand new, highly efficient, and safer traffic procedure just to avoid getting in each other's way.
That's amazing. An organic safety improvement born out of annoyance.
Exactly. But whether it is a massive top-down restructuring or an unplanned floor-level adaptation, the safety professional has to have their radar on.
Always scanning.
There is a profound concept in the SPAN CSP source material that I want to highlight. It says sensitivity to impending or probable change is a key component in the work of a good safety professional.
I remember reading that. It highlights a specific, almost invisible phenomenon, right? The compounding of change.
The compounding of change is what keeps process safety engineers awake at night. If we connect this to the bigger picture, it explains why seemingly stable systems suddenly fail catastrophically.
You know, I read this and I immediately thought of the game Jenga.
Oh, the blocks. Yes.
Unmanaged changes are like pulling Jenga blocks out of the bottom of the tower. You pull one block, maybe you switch to a cheaper, slightly more corrosive cleaning chemical. The tower doesn't fall?
Nothing happens immediately?
Right. You pull a second block, management cuts the maintenance budget, so inspections happen every 6 months instead of every 3. The tower still doesn't fall, but you've left the structural integrity silently hollowed out.
It's incredibly fragile now.
And then, a year later, a totally normal vibration from a forklift driving by causes the whole thing to collapse. And everyone blames the forklift driver, completely ignoring the missing blocks that actually set the stage for the disaster.
The changes just sat dormant until they interacted.
Exactly.
That Jenga metaphor is absolutely spot on. The compounding effect means the root cause might be buried 2 years in the past. It's a subtle combination of minor, unmanaged tweaks that finally cross a critical threshold of risk.
It's terrifying when you think about it.
It is. When a client tells me we haven't changed anything in our process, but suddenly we're having a spike in accidents, my immediate instinctual response is, you absolutely have changed something. You just haven't realized it yet.
That brings up a massive blind spot for a lot of companies, and it ties right back to our opening story about the 1974 disaster in England.
The Flixborough bypass pipe.
Exactly. How do we deal with temporary changes? Because I see this all the time in the field.
Oh, temporary changes are the worst.
A bypass valve is installed, or a machine guard is removed for a quick alignment, or a short-term staffing shift is implemented because someone called in sick. These completely fly under the radar.
Because it's just a Band-Aid.
Right. People think, oh, it's just a temporary fix. It's just for a few days until the new parts arrive from the supplier. But while that temporary fix is operating, it carries the exact same risk profile as a permanent change, doesn't it?
Honestly, it often carries a significantly higher risk profile.
Because it's rushed.
Precisely because it is makeshift. It lacks the robust engineering, the testing, and the documentation of a permanent solution. This is exactly why the ISO standard explicitly calls out planned temporary changes. A temporary change must go through the exact same rigorous risk assessment.
Let's give a concrete example of that so listeners really grasp it. Let's talk about bypassing a safety interlock.
That's a great, terrifying example.
For anyone not familiar, a safety interlock is essentially a digital or mechanical tripwire. If you open the door to a massive industrial shredder, the interlock automatically cuts the power so you can't reach in while the blades are spinning. It is a fundamental safety net.
Right. And if that interlock switch breaks, production stops dead.
Which managers hate.
So a maintenance worker might bypass the interlock, literally hot wiring the machine to think the door is always closed just to keep production running for 3 days while they wait for a replacement switch.
I've seen that happen.
If you do that, you are operating a highly lethal piece of machinery without a safety net for 72 hours. And Mo's process forces the organization to stop and ask, how are we mitigating the risk for those 72 hours? If we bypass this digital tripwire, do we need to implement a strict lockout, tagout procedure for every single material jam? Do we need to station a dedicated safety watch at the machine?
You cannot give temporary changes a free pass.
Never. The hazard doesn't care if your fix is temporary. Physics will operate exactly the same way.
Okay, so we know what triggers a change. We know we have to watch out for the compounding Jenga blocks and the temporary Band-Aids.
Right.
But practically speaking, if I'm a safety manager on a Tuesday morning and a foreman comes into my office wanting to swap a chemical pump, what is my immediate first move to defuse that potential bomb? How do we actually manage it? We need a framework to organize the chaos.
And the sources provide a very clear chronological map for this. The architecture of MOSA is broken down into 3 distinct, non-negotiable stages: prior to the change, during the change, and after the change.
Very logical.
And all of this maps perfectly onto Deming's PDCA model plan, Do, Check, Act. The sources emphasize heavily that PDCA isn't just a buzzword, it is the operating system of any successful business or safety program.
Okay, let's look at the plan phase, which is everything that happens prior to the change. When you look at how the chemical industry handles this, because, let's be honest, they wrote the book on process safety, they've actually boiled this survival guide down to 7 distinct steps.
The 7 steps of MOSA?
Exactly. Step 1, identification to change. Step 2, assessment of impact. Step 3, risk assessment. Step 4, evaluation of alternatives. Step 5, approval process. Step 6, implementation. And Step 7, monitoring and review.
That's the gauntlet.
But instead of just reading that list, let's walk a real-world scenario through it.
Yeah.
Let's say our facility wants to switch from a traditional, highly effective industrial solvent to a new, environmentally friendly green solvent. Walk me through how these steps uncover the hidden risks.
I love that scenario because it happens constantly and it almost always catches companies off guard. So, step 1, identification. Management identifies the desire to switch to the green solvent to meet sustainability goals.
Sounds great so far.
Step 2 is the assessment of impact. This is where we look at the actual physical properties. The safety team realizes the new green solvent, while better for the ozone layer, actually has a much higher vapor pressure and a lower flash point than the old stuff.
Uh-oh.
Yeah, it evaporates faster and ignites easier.
Which immediately triggers Step 3, risk assessment. The team realizes that because it evaporates faster, the existing ventilation hoods over the workstations are no longer strong enough to pull the fumes away from the workers' breathing zones.
Exactly.
Plus, the current nitrile gloves the workers wear might degrade when exposed to this specific new chemical compound. Suddenly, a simple green initiative has introduced respiratory hazards, fire hazards, and chemical exposure hazards.
Precisely. And that brings us to step 4. Evaluation of alternatives. We realize the risk of just swapping the chemical is unacceptable.
So do we just give up?
No, we don't just throw our hands up and cancel the sustainability initiative. MOC forces innovation. We ask, can we achieve this goal a different way? Maybe we find a different green solvent that has a higher flash point.
Right.
Or if we must use this specific one, we evaluate the alternative of upgrading our ventilation system and buying specialized chemical-resistant gloves before we allow a single drop of the new solvent into the building.
That perfectly illustrates why Step 5, the approval process, is so critical. The Center for Chemical Process Safety text is very strict here.
Incredibly strict.
It mandates that qualified personnel reviewing the change request must normally be independent of the MOC originator. And furthermore, the final approval often has to come from another designated individual who is independent of the review team. Why all the layers?
Because of cognitive bias. The originator of the change is inherently biased toward its success.
Makes sense.
If the sustainability director proposes the green solvent because their year-end bonus is tied to reducing the company's carbon footprint, they have a massive, glaring blind spot to the risks. They will unconsciously underestimate the fire hazard and overestimate the environmental benefit.
So they need a neutral party.
The independent review acts as a circuit breaker for that bias. They don't care about the sustainability bonus, they only care about the physics of the vapor pressure and the integrity of the ventilation system.
I've always thought of it as grading your own homework, but with much higher stakes. If you let the production manager approve changes that make their line faster, you are virtually guaranteeing an accident. You need someone who is completely insulated from the production pressures to hold the line on safety.
Exactly. When you skip evaluating alternatives and you skip independent review, you turn MOC into a bureaucratic roadblock rather than a powerful engineering tool. It just becomes a pencil-whipping exercise.
Okay, so we have the framework on paper. We've got our 7 steps, we've walked our green solvent through the gauntlet, and we understand the vital need for independent reviewers. But frameworks are just theory until you put people, money, and resources behind them, right?
That's where the rubber meets the road.
So what are the specific elements that actually give a MOC program its teeth in the real world?
An MOC program is a living system, and it requires a robust ecosystem to survive. The reference guide lists the core elements necessary for a successful program.
Let's hear them.
They are leadership alignment, stakeholder engagement, communication, change impact and readiness, training, and organizational design. If any of those pillars are missing or weak, the MOC process will eventually collapse under the pressure of daily operations.
And for those evaluating this from a certification standpoint, there is a very specific framework you need to deeply understand regarding change management. It is known as the 7 R's.
Yes, the 7 R's, crucial exam topic.
This is a core competency. The 7 R's are reason, resources, who raised the request, return required, relationship, and risks involved.
Right.
But just listing them doesn't really do them justice. To really understand the 7 R's, I want to go back to that vivid scenario. We opened this QHSE Talks with the 1974 disaster at the Flicksboro chemical plant, because that tragedy maps perfectly onto a failure of these exact elements.
That is a phenomenal case study for this. For context, the Flicksboro Works was a chemical plant that oxidized cyclohexane. It was a highly pressurized, highly volatile process.
Basically a bomb waiting to happen if not managed.
Exactly. They had a series of 6 massive reactor tanks connected by large pipes. One day, reactor number 5 developed a vertical crack and began leaking. To keep the plant running, management decided to remove reactor number 5 entirely and install a temporary bypass pipe connecting reactor 4 directly to reactor 6.
Okay, let's run that temporary bypass pipe through the 7 R's. First, reason. Why were they doing this? The reason was purely financial pressure.
Right, they had to keep producing.
The plant was a major supplier of raw materials for nylon, and there was massive demand. They felt they couldn't afford a complete shutdown for a proper repair. The reason was speed, not safety.
Next is resources. Did they have the engineering resources to do it safely? Absolutely not. The site didn't even have a fully qualified mechanical engineer on staff at the time.
That is wild.
The bypass pipe was literally sketched out in chalk on the shop floor. They used a 20-inch pipe to connect 2 28-inch flanges using makeshift scaffolding to support the massive weight and pressure. They lacked the intellectual and physical resources to execute the change.
Then we have who raised the request and return required. The request was raised by plant management under intense pressure to maintain production. The return required was keeping the product flowing to avoid losing market share. The financial incentives entirely blinded them to the operational realities.
The 5th R is relationship. How does this change interact with other systems? This is where they failed catastrophically.
This is the interconnectedness we talked about earlier.
Yes, they didn't calculate the relationship between the fluid dynamics of the highly pressurized cyclohexane and the dogleg shape of the temporary pipe. They didn't account for the shear stress and the bending moments that the pressure would exert on the makeshift scaffolding.
And that leads directly to the final R, risks involved. Because they didn't do the math on the relationship, they completely failed to identify the risk.
They were totally blind to it.
2 months later, a slight pressure surge, which, by the way, would have been easily handled by the original robust reactors, caused that makeshift 20-inch pipe to squirm, buckle, and completely rupture. It released massive amounts of boiling cyclohexane vapor, which found an ignition source.
And the resulting explosion leveled the plant.
When you look at the 7 R's, they aren't just academic bullet points. They are a forensic checklist of how human beings rationalize themselves into a disaster.
And that history is exactly why leadership alignment, the first element of the MOSA ecosystem we mentioned, is so critical. The text makes a very strong, uncompromising statement here.
What does it say?
It says trying to change the organizational culture without changing the environment within which that culture operates is absolutely doomed to failure. The leadership messaging must be absolute and consistent.
Because actions speak louder than memos.
Exactly. If a CEO publishes a memo saying safety first, but then a floor manager screams at a maintenance tech for delaying a process by filling out an on-C form, the true culture is revealed immediately. The tech learns that speed is valued above safety.
Right.
Consistent leadership messaging is the only way to break down the natural resistance barriers to the required bureaucracy of MOSA.
Here's where it gets really interesting, though. Let's say you are the safety professional embedded in an organization. You know the history of Flicksboro. You know the 7 R's. You know you need a rigorous MOC process for the new green solvent or the new machinery.
You know what needs to be done.
But you have to get executive leadership aligned, and they are balking. They're looking at the spreadsheet, complaining about the cost of the change, the cost of the new ventilation, or the downtime required for the training that goes with the change. How do you actually convince a skeptical executive?
You have to step out of the safety silo and speak their language, and their language is finance and risk management.
Money talks.
Always. If you look at how the Board of Certified Safety Professionals evaluates this exact scenario, they don't want you making emotional or moral pleas to management. They expect you to act like a financial officer.
Really?
Yes. The most effective way to convince senior management that the company will receive value for money spent on training and MOC processes is to use a hard cost-benefit analysis. You have to put a spreadsheet on their desk that directly compares the training and implementation costs to the potential injury and liability costs.
So make it a pure business case. You don't just show them course evaluations or tell them it's the right thing to do to keep people safe. You show them the math.
You have to show them math.
You show them that the cost of an unmanaged change resulting in an incident like the skyrocketing workers' compensation premiums, the lost production days, the massive regulatory fines from OSHA or the EPA, and the devastating reputational damage vastly, vastly outweighs the cost of the specialized gloves, the ventilation upgrade, and the 4 hours of downtime for training.
Exactly. You show them that MOC is an investment in operational continuity, not a sunk cost.
It's insurance.
Right. Okay, so we've planned the change. We've used our cost-benefit analysis to get leadership fully aligned. We've analyzed the 7 Rs to ensure we aren't repeating the mistakes of the past. Now we are moving into the do phase of the PDCA cycle.
Time for action.
It is time to actually pull the trigger and implement the change.
But even execution requires a meticulous approach, right? You can't just yell, okay, everyone, start using the green solvent.
Definitely not.
The guiding principle here is implement, if safe. Before you touch a single piece of equipment or open a single barrel of new chemical, a detailed action plan must be established. We are talking about defining specific tasks, setting acceptable timelines, assigning accountable parties, and identifying the exact training requirements before the new process goes live.
The text strongly suggests using established project management tools for this, like Gantt charts.
Gantt charts are great for this.
For those unfamiliar, a Gantt chart is a visual timeline of a project that shows how different tasks are interdependent. You can't start task C until task B is finished.
Right.
In our green solvent example, the Gantt chart ensures that we don't bring the solvent onto the floor, which would be task C, until the new ventilation system has been installed and tested, task B, and the workers have been trained, task A.
It forces order.
This shouldn't just be an email thread. It needs to be managed with the rigor of a major capital project.
And you mentioned training, which is a massive component of implementation. Let's pull another critical insight from the sources here. If you are rolling out a new procedure due to a change, you need people to actually remember it under pressure.
Retention is key.
Right. When evaluating training techniques, the data shows that the method providing the greatest participant retention isn't having them read a dense manual, and it isn't making them sit through a 2-hour PowerPoint lecture.
We all zone out during PowerPoints.
We really do. The highest retention actually comes from students actively participating in a training game or some sort of hands-on simulation.
That speaks directly to the human element of change management and adult learning theory in general. You are asking experienced adults to break ingrained muscle memory and abandon old habits. Passive learning just doesn't work well for that.
They need to feel it.
They need to physically engage with the new system. If we are changing a lockout tagout procedure for a new machine, they need to physically walk up to a dummy panel, apply the lock, and pull the tag.
Exactly.
And during this implementation phase, the role of the safety department is very clearly defined. Their job is not to stand around with a clipboard writing up non-compliance tickets. Their job is to be on the floor, providing real-time technical and safety assistance to workers as they navigate the new process.
Yes. The safety professional is there to foresee operational challenges. They are looking over the horizon while the maintenance workers are hyper-focused on the immediate task of installation. They are asking things like, now that this machine is installed, does its new footprint block the emergency exit route?
That foresight is critical. So what does it actually mean to implement the change, if safe? It means that the MOC process acts as a final, real-time gatekeeper. During the change, which is the second major stage we identified earlier, the impacts on safety must be monitored in real time to manage unanticipated variables.
You can't just walk away.
You don't just flip the switch, declare victory, and walk back to your office. For example, if you are upgrading the software on a process control system in a refinery, The performance of the system is monitored constantly by engineers.
Waiting for a glitch.
Right. If a pressure sensor starts reading erratically under the new software code, that issue is addressed immediately, potentially halting the rollout before it cascades into a pipe rupture.
And communication is the absolute lifeblood of this phase. If you are monitoring and you see an issue, or if you are preparing the workers for the rollout, the way you relay that information really matters.
How you say it is as important as what you say.
The sources dictate that the communication of hazard control information should include information that is clear, specific to the audience and situation, and crucially, states the expected outcome.
Right.
You don't just blast a highly technical, jargon-filled engineering email to the floor workers. You translate it. You tell them specifically, we're installing the new high-flow valve today. Because it operates at a higher pressure, expect a significantly louder release sound during venting, and ensure you are standing firmly behind the newly painted yellow line. Clear, specific to the audience, and states the expected outcome so they aren't startled when it happens.
That is a perfect example of tailored communication. So the change is implemented, the machinery is running, the green solvent is being used, the new valve is holding pressure. Are we done?
Definitely not.
Can we close the MOC file? Absolutely not. This is the exact moment where most organizations fail. We have to move into the check and act phases of the PDCA cycle. We have to audit and monitor.
Right. Because how do we know the change actually worked the way we intended in the real world, rather than just on the engineering blueprints?
Exactly.
How do we know it didn't create a new, invisible problem that is slowly compounding like our Jenga tower? We move to the final stage of MOC, after the change.
This involves rigorous, scheduled monitoring of the change post-implementation. You have to ensure it hasn't introduced new risks or created unintended behavioral consequences over time. And we do this through the formal audit cycle.
What's the main goal there?
The primary objective of a worksite safety assessment or audit is straightforward: to ensure strict compliance with applicable internal and external standards.
But the study guide material goes much deeper into the philosophy of audits. It says audits function to address two major components: the identification of gaps and the measurement of program effectiveness.
Both are critical.
First, are people actually following the new procedure we implemented? Are they using the new chemical-resistant gloves we bought, or do they switch back to the old ones because they are more comfortable? And second, if they are following the procedure, is it actually keeping them safe? Is our incident rate going down?
And there is a critical, non-negotiable rule here regarding deficiencies found during an audit.
What is it?
If you find a gap, it must be corrected immediately, and it must not appear on subsequent reviews. If you do an audit in Q1 and find people aren't using the gloves, and you do an audit in Q3 and find the exact same thing, your MOC process is fundamentally broken. Your ACT phase in the PDCA cycle has completely failed to correct the system.
And that failure circles us right back to Peterson's warnings about superficial fixes. This is a vital concept for understanding the limits of engineering. Standardized operating procedures, newly written policies, updated job descriptions, they might lower the risk profile in the short term.
So on paper.
But Peterson argues that if these structural changes don't address the shared values and social norms of the workforce, they will inevitably be undone over time. Human beings seek efficiency. Workers will slowly revert to the old, faster, or more comfortable way of doing things if the underlying organizational culture hasn't actually shifted to value the new, safer method above raw speed.
What's fascinating here is, well, when you look at it through that wide lens, an MOC program isn't just a safety tool. It's not just a binder full of forms designed to keep OSHA inspectors happy. It is a fundamental business optimization tool.
I love looking at it that way.
When it is implemented correctly with rigorous auditing and cultural alignment, it creates stability. It drives operational efficiency by preventing unexpected downtime. It reduces the overall uncertainty of the manufacturing process. It forces a company to be deeply intentional about how it evolves in a competitive landscape.
It absolutely is a business optimization tool, and the best safety professionals treat it as such. And for the candidates listening, let's ground this in the professional realities of the ASP and CSP certifications.
Big call.
To even qualify to sit for these exams, the credentialing board requires that professional safety functions must comprise at least 50% of your daily duties. And those duties must involve a significant breadth of hazards and a degree of professional charge.
It's a high bar.
Understanding and executing management of change isn't just a bullet point you put on a resume to get an interview. It is the very definition of evaluating and controlling hazards through complex engineering and administrative approaches. It is the essence of being a true safety professional. You aren't a cop. You are the architect of the system's resilience.
You are the architect. I love that framing.
Okay, let's take a breath and synthesize the massive journey we've just been on during today's QHSE Talks. Management of change is a massive, multi-stage philosophy.
It's huge.
It requires a profound shift away from blaming the worker for swerving to analyzing the mechanical system of the car. It requires vigilance in recognizing the triggers from a multi-million-dollar plant expansion down to a temporary bypass valve or a desk moved into the shaft.
You have to see it all.
It demands a rigorous, unyielding framework. Independent review so we aren't grading our own homework, meticulous implementation tracking with Gantt charts, and a deep understanding of human behavior to ensure training actually sticks.
And the PDCA cycle.
Yes. Above all, it relies on the relentless application of the Plan-Do-Check-Act cycle. It is all about catching those compounding invisible changes before they interact and catch you.
It's about maintaining control in a dynamic environment. And, I want to leave you with one final provocative thought, something to mull over as you analyze your own operations this week.
How do you hit on us?
Throughout this QHSE Talks, we spent an incredible amount of time, energy, and resources evaluating the risks of making a change. We fill out the MOC forms, we do the hazard analyses, we debate the alternatives in committee meetings, but what are the hidden compounding risks of not changing? How often does an organization's stubborn refusal to adapt to stick with an outdated, poorly designed legacy system or an obsolete piece of machinery just because that's how we've always done it become the biggest, most dangerous, unmanaged hazard of all?
That is a powerful question. The immense invisible risk of standing perfectly still in a highly dynamic, rapidly evolving world. Thank you all for joining us for this deep, comprehensive QHSE Talks. I want to challenge you to walk into your facility tomorrow, look around the production floor, look at the maintenance schedule, look at the new raw materials arriving on the dock, and ask yourself, what changed here yesterday? And who fundamentally understood the risk when they approved it? Keep questioning the system, keep learning the mechanics behind the rules, and keep your people safe. We'll see you next time.